T sub A, T sub B, T sub D. Okay, what else? Julian, what other forces do we have here?
Got the normal force from the block.
Which
Not
one?
normal, the weight of block A.
Weight of A, so WA. And what else do you have?
So
500 Newton. So Matt, you want to look through all these and tell me if we have the magnitude and direction? So how about TC?
we have a direction.
We have the direction, but we don't have the magnitude. I'll put a question mark. How about TA?
EA also direction.
But no magnitude. How about, let's keep going. Gabby, how about you? What about TB?
Direction, yes.
No. And how about TD? Kenzie? Okay, so TD is here though, right? So you know it's going along this line, right? And depending what I analyze, it's either going up or down. But now let's jump ahead. Do we really know what the value is of TD? Cameron, was that you? It's equivalent to the weight, right? We have a weight of block A here, and it's held being suspended by a cable. If I drew a free body diagram right here, so if I had a free body diagram right at that link, weight A would go down, and how would I draw tension? Kenzie? TD would be going up. And then what do I know about these two values? They're going to be equal. How come? What equilibrium equation am I using to determine that? Sum of forces in the y is equal to TD minus WA equals 0, and TD is equal to WA. So even though it is an unknown, and it requires an equation, I think that we could say that we can jump ahead on that and just say that this tension is the same. TD is equal to weight A. So we're not going to put this on there. We're not going to say it's unknown. So you can keep it on here as TD, but then you're going to check off that you know what the value is, and you could write WA. Is everybody okay with us jumping ahead and just saying, hey, we know what that tension is because it's suspended from what a weight is suspended from it? Okay, Kenzie, how about WA? Do we know WA?
Yeah.
We don't.
No,
No, we don't. But do we know the direction?
yes.
Yes. Arturo, what about 500 newtons?
We know both the direction and magnitude.
We know the direction and the magnitude. So, Arturo, how many unknowns do I have?
4.
1, 2, 3. I have 4 unknowns. So how many equations do I need? 4 equations. And I already know from above, how many equations can I get from each body? 2. Everybody look up here. For each body, I can get 2 equations when it's a 2D problem. I know there's no motion, there's no translational motion. For each body, I have 2 equations. But how many equations do I need for this problem? 4. So how many bodies do I need to analyze? Huh? 2 bodies. So now let's figure out what bodies I want to analyze. I'm going to pick this one up. So talk with the person next to you. What bodies do you want to analyze?
Ignore the mass.
What do you want to analyze? What do you want to draw free body diagrams of?
Yeah, let's say that's the top. It's just like so that the wall of the ceiling.
I'm thinking joint 1 and joint 2. only graded I only graded one. Joanne's gonna do the.
Okay, how about instead 1 and 2? Agreed? That wasn't very easy. Yeah. We're gonna change that, please.
It was the tired.
So let me interrupt for a
I
minute.
wanted to would be fine because I think you have 3 wheels.
The first part of the, maybe we have one more week, we're only looking at translational motion. We are only looking at preventing translational motion. I'm not introducing rotational motion yet. So how do you only get translational motion? When the forces are concurrent, they're all acting on the same point. So thinking about that now, can you find places where the forces are acting on the same points? And where are they? Point 1 and point 2, joints, I think there's a link there. So this is a great point to analyze because all these 3 forces come into it. And this link right here is a great place to analyze because all these 3 come into it. So now draw a free body diagram of joint 1 and of joint 2. I'm going to draw the axes on here. Do I always need to draw axes on free body diagrams?
Yes.
Yeah. Okay.
Pay attention to
Yes, yes. And Daniel asked if instead of drawing the free body diagram, drawing the axes on the free body diagram, is it okay to just draw the axes off the free body diagram? And the answer is yes. And there are times that it might be easier to draw it on, and there might be times that it's easier to draw it off. As long as you have the axes drawn, you're cool.
Oh, sorry, angle X. Oh, sorry, I was just looking that's like how I do my
Even all of the tension, all of the weight, you can just say, narrow and say, oh, you should.
It's like a skin.
Yeah.
At the beginning. But then I was the thing that he drew there over this
Kind of see like
Try,
yeah.
yeah, probably.
Anything else?
I didn't want to
Ben, someone's. Okay, let's